Hi, it's teardown time. If you've been following me on Twitter, you'll know that I got this new Focusrite Scarlett Solo USB audio interface to replace my pain in the ass Rode AI-1, which I've been having quite a few issues with, which started with Zencaster, which I used to record the Amp Hour podcast. It started not to recognize it. And more recently, I've had issues with this thing where I'm doing like a screen capture recording or something, and it'll just, like, the mic will just drop out completely, and I've had to actually reshoot several videos now, like a screen capture, whether I'm doing a screen capture or like adding a voiceover to a video or something like that. It's just dropped out, and it's not the software. It seems to be something to do with the USB interface, the drivers, whatever. I've tried updating the firmware and no luck. I'm jack of it. So everyone recommended the Focusrite. There's a 2-channel version, but I don't need that. I only have it need a single microphone input. But they're basically identical price, near identical size. The Rode is a little bit smaller, and they've both got balanced 6.5mm 1/4 inch for you Yanks. Output USB-C. Input's got a Kensington lock. Why you need that, I don't know. Is somebody going to steal your thing? Maybe. Anyway, near identical functionality, except the Focusrite does have the extra instrument input. You know, if you're doing vocals and guitar at the same time, it's like popular for that. But I'm only using it for its phantom power here. It's got some airy-fairy, arty-farty tube sounding thing or something. I don't know. I don't care. Anyway, yeah, phantom power, microphone input. That's all I use it for. Monitor output here for driving, because the balanced outputs here go to my Focal CMS 40 studio monitor speakers, and I don't use the direct monitor thing. I'm not someone who likes to listen to my own voice. Trust me, you've edited 2,000 videos of your own voice, you get sick of your own voice. Not that I have a radio voice. Anyway, I'm infamous for my voice, aren't I? I've actually been recognized on the street by my voice, and not they actually heard me and they go, "That's Dave." Yeah, all right. Anyway, direct monitor output and headphones, and nice feeling monitor controls on these, and microphone gain settings. They feel like, you know, not loosey-goosey, nice and solid. I like that, nice and firm, a bit better than the Rhodes. But anyway, let's do a teardown of both of these and see what's what. Yeah, so as you can see, like near identical size there, but the Rode is slightly smaller, but of course this one has the extra instrument input. So anyway, yep, let's crack it open. I've lifted it up a little bit. There's 2 screws on the back here, I think, under these feet. There's not 4, there's only 2, which is weird. So I have done a teardown of the Rode before, way back, but it was, I think, dodgy video quality. I'm going to use my Tigano here. Yep, there we go. Phillips. Oh, these are bloody self-tappers. Are you kidding me? Unbelievable. That's like, why self-tappers? Oh, come on. If you don't believe me, there's nothing under there. There you go. It's only got them on the back. So I presume that once this comes out, it'll just slide out the front. And, because there's nothing holding the rear ones in. But anyway, self-tappers. So, oh yeah. Yep, there we go. Oh, we're in like Flynn. Check it out. There we go. That's nice. There it is. There's the bottom side there. No, it's not warped. That's just my lens at wide angle here on my Tigano microscope. And there you go. Yeah, that's where the screws went. It felt like they were going into plastic. So there you go. All right, so first of all, it's a double-sided load. So yeah, we've got a ribbon cable going off to, oh, what looks like, the front panel there just looks like a single-sided phenolic bass jobby. None of that FR4 rubbish. We've got, obviously, a bunch of bypass caps on here, so we're going to have a little pain-in-the-ass package on the top side there. We've got a couple of SO8s, but let's flippity-doo-dah and have a look. Oh, there we go. XMOS. There you go. Ooh, XMOS processor down there. Oh, that's interesting. You don't get to see the XMOS, but hey, check this out. Ribbon cable shielded. That's a nice attention to detail, although it's not... Is it grounded? No, it's just flapping around in the breeze, I think. But anyway, that's a nice looking layout. I don't know what's going... debug. Okay, so that's a debug header. It's interesting that they've obviously got a custom little bed of nails or probe, custom probe that goes into there to do program debug and stuff like that, factory debug and, well, I presume programming. Although you might, you could buy the processor pre-programmed, I guess. Focusrite Audio Engineering. By the way, the Focusrite, I do believe, and don't quote me, but I do believe it has slightly better dynamic range, like an extra 3 dB or something, better dynamic range than the Rode AI-1. So there you go. So yeah, there's that LED board. Yeah, I thought it'd only be used for the LEDs. Why waste money on that double-sided FR4 rubbish when you can get the phenolic base? They're screwed in there because this thing does have LEDs around here that light up green, yellow, and then red for peak. I'd love to see like a little bar graph on there, like a 5 or 6 LED bar graph. That'd be really nice. But there's not many bar graph USB interface ones on the market. So anyway, are they Burns? No, we don't have any part number on the pots, so I can't tell you about the pots. Yeah, it's a pot. It's got VR, and there's the other pot in there as well. That's a dual gang jobby. And yes, this is the Gen 3, by the way. 105 degrees C rated caps. What brand are they? Oh, Crapson. Okay, yeah. It's built down to a price. Meh, what do you expect? Oh, for you Nutric fanboys, there you go. It is a genuine Nutric. Excellent. Well done. Right, so here's our microphone input. Let's have a look down here. There's a... Oh, is that a little... That looks like a little common mode choke, is it? Yeah, I do believe we have a common mode choke. That's a nice attention to detail. Keep out the high frequency nasties. And then looks like the mic amplifier is a JRC 2122. There you go, ultra low noise dual op amp. 1.5 nanovolts per root hertz. That's not too shabby. It's all bipolar, none of that CMOS rubbish. Get it around the right orientation. Don't want all the electrons to fall out when it's upside down. So we've got some test points down in there. There for our, there's our preamp. Yep, preamp positive and negative test points. So that's our balanced amp. Yeah, so that's our mic plus and minus input. They've got inductors on the rails too. That's nice touch. Don't know why D2 is missing up there. Anyone know? And there you go, R78, R79 missing. I don't know. Maybe it's something they had at the design stage. I don't know. Is there another? Well, no. Well, there is another model, but it's physically different to this. It's like the dual channel input or whatnot. So yeah, not sure what the deal is. Not sure why we got our dual transistor stage there. What's going on? Anyway, and there's 8065s there. We could have a look at that. Once again, Japan Radio Corp, they get almost every design win in, low-cost gear. It's, well, even the higher-end gear. They're just everywhere. Anyway, high gain, wide bandwidth, dual op amp, 10 meg gain bandwidth product. No wuckers. Right, so I'd presume that they're the output drivers for our line outs here. So they would have to be. Let's get our ribbon out. Absolutely no surprises for finding the Cirrus Tech CS4272 there. Cirrus Tech are in pretty much everything in the audio domain. So let's have a look. That's a 24-bit jobby, 192 kilohertz, none of that 96 kilohertz rubbish, 114 dB dynamic range, differential, of course. It's got integrated volume control, selectable digital filters, all the rest of it, it's I2S. Meh. So that's a 24-bit D to A and A to D, 192 kilohertz, none of that 96 kilohertz rubbish, minus 100 dB THD for the DA. Oh, well, for both. And both 114 dB dynamic range for both. Yeah, I do believe the dynamic range is slightly better, as I said, than the Rode Jobby. It's got a high-pass filter in there. See, that would have been nice. I would have loved, because I actually, for my microphone input to stop my mic rattling, when I move it, shake the desk or whatever, or, the pole shakes, I accidentally bump it or whatever. Don't want to get these, low-frequency transits. I've actually got an external inline XLR high-pass filter in there, or low-cut filter for you low-cut fanboys. And yeah, it'd be nice to implement that in this. It'd be nice if they had just an extra button on the front that implemented that, because it does it inside the chip. So that would have been cool. Anyway, it's got all the requisite goodness. No wuckers. Oh no, there's another pair of those 8065 Op amps again, maybe they're, no, they're for the output. Yeah, they're for the output here, given the, okay, these must be drivers for, no? Oh, maybe these get, oh, that's for the monitor. I think that's for the, when you hit the monitor, the monitor button, that will switch. That's right, that will mix in. Yeah, they're for the mix in. So they will actually drive and mix in with the other outputs here. So when you have the direct monitor switch, that's right, that's what's happening there. There's our USB power supply. They're generating V-bus there, and looks like, yeah, that's a little switcher. Don't know what that one is. Not really fussed. Okay, it doesn't look like there's any common mode chokes there on the USB power input. So, because I've had kind of a bit of an issue with this, it's a bit, somewhat worse than the Rode in terms of ground loops when you unbalance the outputs. So, there's another switcher over there, 3.3 plus 1 volt, is it? They need 1 volt for the XMOS. And of course, there's a 74HC595 serial expander in there because, you know, don't have enough digital I/O on here, so you got to like expand it out. So all the 595 fanboys go wild. I know I do. I'm a fanboy. Love the 595. Anyway, there's our headphone amplifier, MPMS 3425. I can't find any ready info on that. If I do find it later, I'll include it in an overlay. So yeah, and well, that's about all she wrote, really. Where's our phantom power amplifier? Is that tucked down under there, perhaps? -6 plus 5 VA? No, that's voltage analog. Oh, we forgot on the back. Haha, there's stuff on the back. Okay, so our XMOS processor down there, that's our that's USB to I2C, basically, where it's going to talk to our Cirrus Logic chip up here. And so that's an XMOS processor. Interesting choice. None of that, you know, ST and other ARM rubbish that they have these days. So let's have a squiz. I do believe it's the 200 series. So multi-channel audio platform, two hardware manual, multi-core microcontroller device, analog input audio channels, digital input MIDI. It's got USB, it's got flash, it's got multi-port maps and what? Anyway, this is the user manual, so this is not the data sheet for the chip. I couldn't get the exact one, so the X-Core 200. 8 analog audio, 8 output, 8 input analog audio channels. So a 2-tile X-Core 200 device. So yeah, it's, what was it, 208 or something that we had here, I think. Yeah, we've got like, it looks like it says GT205, so I presume we've got the X-Core 205 here. Providing 8 logical cores, total up to 1,000 MIPS. Compute power, awesome. A total of 53 general purpose I/O, and they still needed the, well, not on this, I don't think we've got that high a pin count here, but yeah, they still needed the 595 expander. That's great. Anyway, there you go. It's going to have a USB input. It's got some SRAM. It's got one-time programmable memory, and yeah, JTAG interface, and all the rest of it. Analog audio input channels. Anyway, back on the bottom here, that's our LED board interface there. What have we got? Ah. No, I thought that was micro for a second. No, 25L. Okay, so that's I2C memory. They've put the little mark on there to tell you that it's been programmed, I would suspect. As I said, that's the bottom bypassing of our XMOS processor. Another 8065 dual op amp there. And JRC. There's another JRC 2122 low noise op amp. Okay, it looks like we've got some diode protection happening there. Oh, almost missed one. 4053 analog mux, classic. Yeah, old school. No, still used these days. I mean, you know, geez, I was using them when I was a kid. Long, long time ago in a galaxy far, far away. That movie probably came out at the same time I was using one of these. That cap there is a Yuscon. So we got Crapson and Yuscon. Stills a lot of confidence, doesn't it? Oh boy. Doesn't matter. Like, they're not going to sound any different. But, you know, if you want to recap it with your, you know, $100 capacitors, go for it. I guarantee you, if you pay like $100 for some audio grade capacitors, you're gonna hear the difference. Just don't expect your friends to. Anyway, there you go. We've probably seen it all now, and that's not too shabby at all. Interesting choice with the XMOS Pro. I better stick that back in, otherwise I'm just going to forget. And I'm going to screw it back together, and I'm going to wonder why it's not damn well working. So yeah, that's pretty much what I expected. Didn't expect the XMOS processor. That was kind of the only surprise in there. And yeah, they went for the double-sided load. Couldn't, you know, when you got the small form factor like this, it is surprisingly hard, because that top part, you know, it's pretty well populated. You know, you might think, if you're gun-ho PCB designer, you might think, I can fit all that on the top layer. Well, yeah, give it a go. Yeah, trust me. Yeah, they would have had to go bottom side anyway. They're probably just for, you know, the bypassing on here anyway. Once you decide that you got a couple of caps on the bottom layer, well, you know, all bets are off then. But yeah, that's just pretty groovy. I like that. Not bad for the cost. The Scarlett Solo. You know, it's not using world-class caps in there by any stretch of the imagination, but no, it's nicely laid out, seems to do the job, and I have no doubt that that will meet its performance requirements. So yeah, that's interesting. Let's do the road. Of course, the big difference here, made in Australia. Bloody beauty. Yeah, absolutely. And it feels like this feels more rugged than the Focusrite. Like, Focusrite's okay, but yeah, this just feels like a beefier bit of kit. So anyway, let's get into this. Can't remember. Did I? No. Yeah, they lever out, doesn't it? Oh yeah, there we go. Too easy. There we go. That's some nice design. And yes, I do have an invite to the Road Factory here in Sydney, so I'm going to get around to that one day, but was organised, and then, well, you know, COVID happened. Anyway, that's plastic on the bottom there, but everything else, metal. Threaded metal inserts. Yeah, better than a self-tapper into plastic rubbish. The satisfying sound of metal going clank. Yeah, beautiful. Bobby Dazzler, look at that. There you go. It's pretty sweet. I remember doing this. That's right, I remember some flux residue on the solder joints there, but that's okay. Check this out. This is all machine. This is all machined aluminium. None of that aluminum rubbish here in Australia. That's right, that used something a little bit different, didn't it? So let's lift this board out. They were all metal threaded inserts. Very nice. Look at that. I would say this is a bit nicer than the Focusrite. Not by much. You know, 4580s. There you go. Yeah, classic 4580s. There's lots of 4580 fanboys out there. That's 3 of them, isn't it? Bloody light. And all surface mount are polymer electrodes. You can tell that they're not the electrolyte kind, the liquid electrolyte, because you don't see a vent cap on top. So yeah, that's a bit nicer. Once again, yeah, 595 as well. Absolutely fantastic. Anyway, yeah, we've got an ST Jobby. What's that? I can't remember. Oh yeah, there we go. 32F070 processor. You know, yawn. The XMOS was a bit more exciting there. What do we got? That looks like got a little heatsink there. That looks like discrete power trannies there. Check those out. Yeah, I think we've got some discrete transistors wrapped around the 4580 here. That's interesting. Is that that's the headphone amplifier? Is it? Discrete transistor headphone amplifier? 6287. What is that? Anyway, the main chippy is an NAU88L25. Huh? Oh, Nuvoton. Okay, yep. Ultra low power audio codec for headphone headset applications. 124 dB Class G headphone. Oh, headphone drive. Advanced headset features. Oh, okay, so they're using a headphone audio interface. It's got advanced DSP engine, dynamic range compressor, audio codec. Okay. Sampling rate from 8 kHz to 192. Okay, DAC with auto attenuate, 124 dB signal to noise ratio, 113 dB signal, with auto mute, 101 dB signal to noise ratio, A-weighted. What's the dynamic range? Doesn't say. Anyway, it's just a, yeah, okay, yeah, mic input ADC, okay. It's just, that's an interesting choice. Whereas your Cirrus Logic is your more traditional choice there. So, okay, yep. Yeah, I don't think I took the board out last time, and I won't do it again. They might have some stuff on the bottom. But there you go. That's interesting. In that, you know, it's significantly different. They've used, well, a more traditional processor, the ST processor there. But, you know, discrete headphone amplifier. Discrete transistor amplifier. That's interesting. And then interesting choice for the ADC. So there you go. They're significantly different and significantly different construction. I think the Rode is slightly cheaper, and which is amazing considering that it's made in Australia and it's in like this machined, like, you know, die-cast case, right? So yeah, it's like, you got to say, like the Rode feels like better quality, more rugged, that kind of thing. But yeah, I think technically it's lower cost. Oh, I didn't have a look on the top there. There you go. Not much doing. They haven't used any of that connector rubbish there. Just straight over. But yeah, that's interesting. But yeah, I don't know why I'm getting all the issues that I do. Just compatibility with Zencaster and all sorts of issues. So yeah, but there you go. There's an interesting comparison between two different units. We'll put them side by side. There you go. Look at that. Got your plastic chassis here. You got your machined alloy case here in the Rode mic, made in Australia. I'm sure that isn't made in China. Focusrite. Designed in England, made in China. Yeah. Go figure. But yeah, I think the Focusrite is either the same price or, you know, a couple of bucks more or something. You know, I'm sure prices vary in your country, but yeah, basically, both the same specs, and you know, both of them are pretty decent quality considering that this is pretty much bottom of the line unit. Both of them are about, well, 180 Aussie bucks or something like that. So yeah, not bad value at all, and both of them work superbly. Except, yeah, I've had compatibility issues with the Rode one only recently. Like I used it for a couple of years, no problems whatsoever, and then something changed. I don't know, Windows changed or something, and yeah, I've had issues even with the updated the firmware updating. I don't know about the Focusrite. If it can do firmware updating over USB, I got no idea. But the Rode one, oh, mwah, beautiful firmware updating. You just download the little firmware update program, and it just does it. Nice user interface. It tells you what your old version is, new one. Do you want to update? Yep, boom, done. Absolutely fantastic. So yeah, terrific. But there you go. That's an interesting difference. You know, both of them, yeah, Nutrix as well. Both of them use, you know, proper connectors. You know, cheap quality caps in here, but for the price, like, yeah, what do you expect? Anyway, hope you enjoyed that little interesting comparison between the Focusrite Scarlett Solo and the Rode AI-1. If you liked it, please give it a big thumbs up. As always, discuss down below. Catch you next time. They've got a separate PCB for that. So that kind of makes sense, because this sort of form factor, when you've got either you get a right angle version of this, I don't know, like if they were available in a right angle, then you'd think that they'd use the right angle, but then the problem becomes trying to get the thing in. When you lower it into the case, it's harder because you know, because it's got to stick out the front of the case like that. So maybe having a, but look, they've got a custom plastic bracket and everything on the back of that. That is really quite nice. Yeah, the other thing is that if you have a look here, you can see that the connectors go below the capacitors down in there. So this is your 3D envelope design, and this is sometimes, you know, if you've got to do all this manually, it's rather tricky. Rode are probably using Altium Designer, but you know, any high-end package these days, including Altium Designer, have a 3D DRC, a 3D design rule checking. So if you go to all the effort to 3D model your components, and it is a lot of effort if you're just, you know, doing a one-off, like, so, you know, guilty as charged. I don't bother a lot of the time. Although when I worked at Altium, you know, we had people who did 3D models for us. So you just go, oh, can you give us a 3D model for this? Yeah, no worries. Comes back, you know, 10 minutes later and it's done. But for a company like Rode, who design and manufacture a lot of different products, I'm not sure how many they have, but they would have a huge catalog of parts, and you want to reuse, as a designer at Rode, you wouldn't necessarily, you know, you'd be encouraged, you should be encouraged anyway, or as a professional you should just know this, is that you want to reuse the existing parts in your catalog. So you don't want to have yet another reel of components, because they manufacture their own boards. So they'd have their own in-house pick and place machines probably, and you know, they'd all be loaded up with the components. And you don't want, and when you design a new product, the last thing you want to do is use yet another component that you've got to purchase, stock, store, put on the pick and place machines, change over, everything else. So they're trying to reuse as many parts as possible. So doing a 3D model for every single component would be very beneficial to them. And then when you did that, you could say, like, import not only the main board down here, but you can import this board with the 3D models of these, 3D models of the ribbon cable, 3D models of all these connectors and these plastics and everything else, and you could do the knobs, and you could do everything. And you could see at the design stage that capacitor is not going to foul with that. You can be 100% confident that's going to work, because the software will give you it'll just flag it and say these two components are touching. You know, when you put this board in, you know, it can software insert the board, and it knows that they're going to foul. And you know, it really is a very valuable tool, and can save a lot of respin, and you know, get it right the first time. I'm not going to bother to take the board out, because I don't think there's anything on the bottom side of that board that would surprise me, because you want to minimize, you wouldn't go double-sided load unless you absolutely have to. You wouldn't have components on the bottom, because that increases your production thing. You got to flip it over, you got to glue components, a lot of extra production effort required to put components on the bottom side. So only if you had like high density BGAs or something that required decoupling on the bottom of the board would you consider that, or unless you're doing some ultra miniature thing. This thing didn't need to be ultra miniature. It's obviously, like, it is quite small and compact, and I just love the machined case. Is just, you know, a case, but at least that top surface has been machined out, so maybe it's cast and then they might machine it down, the rim down or something like that. I don't know. Anyway, it is a beautiful case. I'm very impressed.